Okay, so the point of this particular example is going to, well, eventually be factoring this particular factorization setup, a difference of cubes, the specific one being x cubed minus 64. But initially, before we get into the factorization process for this, let me focus on this particular product of a binomial times a trinomial here, and just multiply things out, show that in fact this generates a difference of cubes, and then based on that fact we'll be able to use this format then as the factorization setup for a difference of cubes. So let me first just justify that this does generate a difference of cubes by literally just multiplying everything out here. So if I distribute the a from the binomial through all the terms in the trinomial, I'll get an a cubed then plus an a squared b and plus an ab squared. And then I can go through and finish off the distribution by distributing minus b through all of the terms of the trinomial. So that gets you a minus a squared b minus an ab squared and minus a b cubed. So having completed now that multiplication process, you can see that a lot of like terms got generated, and it turns out they end up being opposite to each other, so most of the stuff here is going to cancel out. You can see this plus a squared b will cancel with this minus a squared b. You've got a plus ab squared that'll cancel with the minus ab squared, so the only stuff that's left here is the a cubed that started out that multiplication and the minus b cubed that wrapped it up. So there it is. You can see by multiplication that a minus b times a squared plus ab plus b squared multiplies out to eventually a final result of a cubed minus b cubed. So doing it in that way, reading things left to right as we essentially have here, there's a multiplicative formulation of this. But if you take it now and just turn it around, this equality holds just as well reading it left to right as it would going right to left. So let me take the order and now switch it around right to left. So what this is saying then is that a cubed minus b cubed, the format we've got there, is the same then as, well, exactly what we just multiplied out to get it. That's the same as a minus b times a squared plus ab plus b squared. So that's important in terms of factorization now, because it gives us a pattern that we can always use to factor down a sum of a difference of cubes. So if you look at the format here, the pattern kind of breaks down like this. First off, the factorization for any difference of cubes is always going to break down as a binomial times a trinomial, where the binomial carries through the same sign as the original sum or difference of cubes factorization. So here we had a difference of cubes, there was a minus there. You can see that we ended up getting the minus reappearing in the binomial stage of the factorization. And then the two things that are to either side of that minus sign are exactly the things that are perfectly cubed to get a cubed and b cubed. If you want to get a cubed, you perfectly cube a, so that appears here. If you want to get b cubed, you perfectly cube b, so that appears here. So that first binomial part of a difference of cubes factorization is precisely that difference, the sign carrying through in the middle from the original problem, of the two things that are being perfectly cubed, a and b. And then a pattern kicks in now based on those entries in the binomial to build up the trinomial. And this holds up for a difference of cubes or a sum of cubes factorization. The pattern on the second trinomial factor is always the same. You'll notice here that it starts out with the square of the first thing from the binomial. The first thing from the binomial was a. Over here you square that to get a squared. Then you had the opposite sign from the binomial. Here you have a plus. Well, that's the opposite sign to the binomial here, where it started out as a minus. Then you've got the product of the two things in the binomial. There's AB there. Well, the two things from the binomial were exactly A and B, so their product is AB. And then you add on the square of the second thing from the binomial. Well, the second thing from the binomial is B here. You can see we're adding on the square of that B. So the pattern to finish off the trinomial part of either a difference or a sum of cubes factorization is always the same. Once you've got the binomial nailed down, it always follows through with that process of square the first thing from the binomial, opposite sign from the binomial, product of the two things from the binomial, plus the square of the second thing from the binomial. So that's the format. That's the formulaic structure that you can use to factor down any difference of cubes problem, and that's exactly what we've got now down here, because now we're supposed to factor x cubed minus 64. Well, x cubed minus 64 is exactly a difference of cubes. I guess first you might want to note what things are being perfectly cubed to get that x cubed minus 64. So, you don't need to write this necessarily each time you do one of these factorizations, but it might be helpful here just for this initial example to note precisely what those things are. So the thing you perfectly cube to get x cubed is, I guess, pretty obviously x, and then the thing you perfectly cube to get 64 is a 4. If you think about it, 4 times 4 is 16, times a third 4 gets you 64. So here then, x and 4 are the two things that are being perfectly cubed to get you x cubed and 64, so they're playing the a and b roles in this setup. So when you go to factor this now, the format tells you that it's going to factor as a binomial times a trinomial. So the binomial, recall, then carries through whatever sign is in between the two perfect cubes in the original problem. This time it's a minus, so that difference carries through, and then you bookend that with the two things that are being perfectly cubed to get you x cubed and 64. Those were exactly x and 4. So then once you've got that nailed down, now you kick in that pattern on building up the trinomial part of the factorization. The pattern says you take the square of the first thing from the binomial. First thing from the binomial here is x, so you square it, so that gets you x squared. Then you have opposite sign from the binomial, so we've got a plus here, so we've got a minus here, so then the opposite sign that we'll put is a plus here. The product of the two things from the binomial, so x and 4 multiplies out to 4x. And then you finish off by adding on the square of the second thing from the binomial. Second thing of the binomial is 4 here, so its square is 16. So that follows exactly now with that pattern that we've noted from before. There's the square of the first thing from the binomial, opposite sign from the binomial, product of the two things from the binomial, plus the square of the second thing from the binomial. So there's the factored result, and you might wonder here, because clearly x minus 4 isn't any further factorable because it's just linear. When you look at this thing, the x squared plus 4x plus 16, you might wonder if that trinomial factors down any further. Well, in this case, you can see pretty clearly that it wouldn't be just looking directly. There would have to be, if this were going to factor down, there'd have to be factors of 16 that added up somehow to 4, which just isn't going to happen. You're never going to find those. But in fact, that's no accident. That's the case for any trinomial that comes out of a difference or even a sum of cubes factorization. That trinomial factor isn't any further factorable over the real numbers. So in this particular case then, we are done. There's the fully factored form for x cubed minus 64. It's x minus 4 times x squared plus 4x plus 16.